Hello and welcome to homework R.05. This is all about word problems. Alright, so let's see what we have here. Mary and Amy had a total of 20 yards of material from which to make costumes. Mary used 3 times more material to make her costume than Amy used, and 2 yards of material was not used. How many yards of material did Amy use for her costume? Alright, so we're going to have to set up an equation here to help us solve this. And before we get into the details, just kind of the basic logic here is we're going to take whatever Mary used, we're going to add it to whatever Amy used, we're going to add it to the extra, and all together, that should equal the 20 yards that the problem told us we had. So we already know the extra's 2 because that's in the problem. We've got to figure out what we're going to put in for Mary and Amy. So let's take a closer read here. All right, it says Mary used 3 times more material to make her costume than Amy used. All right, so let's start with a let statement. So we're going to say let Mary equal, and then it tells us she used 3 times, so let's get that 3 down there, as much material as Amy used. We don't know how much Amy used. That's the whole point of the problem. So we're just going to use a variable there and say let Mary equal 3a, a for Amy. All right, and then down here we can say let Amy equal a. All right, we want to use the same variable, and since the problem didn't tell us anything else about Amy, all we can say is that she equals a. So if we go back to kind of our example here, we've got Mary plus Amy plus extra equals 20. So we just said Mary was 3a, we just said Amy was a, and the problem told us that we had 2 extra yards that were not used, so that's our extra, and altogether that needs to equal 20. All right, so we combine like terms here, we get 4a plus 2 equals 20. Subtract 2 from both sides, you get 4a equals 18. Divide by 4, and you're going to get a equals 4.5. Now, the question asked how much material did Amy use? So this 4.5 is our answer. But you want to be careful on these word problems because a lot of times they won't just ask for Amy, they'll ask for Amy and Mary, or they'll ask for just Mary. So it's never a bad idea to just go up to your let statements and plug those things in. So Amy was 4.5, and then Mary was 3 times that, which just works out to be 13.5. But if you just go in there and plug them back up, you're kind of covering yourself in case they ask for both or just one or whatever. But either way, you'll be good. Okay, let's take a look at number 2. 3 brothers have ages that are consecutive even integers. The product of 3 and the third boy's age is 20 more than twice the second boy's age. Find the age of each of the 3 boys. All right, so before we do this problem, let's just talk about consecutive integers. So there's 2 types that you'll usually see with these problems. All right, there's consecutive integers, and then there's consecutive even or odd integers. And you might wonder, why am I grouping even and odd together? Well, we'll see that in a second. So consecutive are things that are just right in a row, so like 3, 4, 5. And what you notice is when things are right in a row, they're going up by 1. So our let statements for these will be x, x plus 1, x plus 2. Even and odd are a little different. So here's 3 even numbers, 4, 6, 8. Here's 3 odd numbers, 7, 9, 11. What you're seeing is, even though these are even and these are odd, in both cases they're still going up by 2. 4 to 6 is up by 2, 6 to 8 is up by 2, same for 7 to 9 and 9 to 11. You're always going up by 2. So even and odd are going to have the same let statements, they're just going to go x, x plus 2, x plus 4. The only difference is when you're doing an even problem, you'll get an even answer for x. When you're doing an odd problem, you'll get an odd answer for x. But otherwise, you set them up the same way. So if we go back here, It says the three brothers have ages that are consecutive even integers. So that means we're using these down here that go up by 2. So we're going to say let x equal the first boy. We're going to say let x plus 2 equal the second boy. And we're going to say let x plus 4 equal the third boy. All right. Now that we have our let statements, let's go back to the problem and try to translate it. All right, so it says the product of 3 and the third boy's age is 20 more than twice the second boy's age. Okay, so the first key here is to know what product is. Product is multiplication, so we're doing 3 times the third boy's age. So the way we would write that is 3. And then to multiply the third boy's age, since it's this x plus 4, we have to put that inside of parentheses. That way it's 3 times both of these pieces. We've kind of learned that that's our equal sign. So we've got our equal sign. 20 is just a 20. More than is an addition sign. And then twice the second boy's age is just going to be 2 times the second boy, which is x plus 2. Now, sometimes kids ask, well, what about the first boy? You don't always use all 3 let statements, so in this case we're only using 2, and that's just fine. So now we want to start solving this. So we'll distribute on both sides. 3x plus 12 equals 20 plus 2x plus 4. Now we're going to combine like terms. So we've got 3x plus 12 equals 2x plus 24. All right, now we have to move the variables and get them on the same side, so we'll move the smaller ones so that we don't end up with any negatives. That's going to leave us with x plus 12 equals 24. And then when I subtract 12 from both sides, I will get x equals 12. So, x equals 12. Be careful that you don't stop here because the problem says find the age of each of the 3 boys. So our first boy is 12. We're good there. But we want to make sure that we write these numbers in for the other 2 boys. 12 plus 2 is 14, and 12 plus 4 is 16. So the 3 boys are 12, 14, and 16. Okay, let's take a look at the back. All right, in big letters, it says use proportions. All right, so let's see what it is asking us to do here. In a game of ice hockey, the hockey puck took 0.8 seconds to travel 89 feet to the goal line. Determine the average speed of the puck in feet per second. Okay, so when we're doing proportions, we like to make ourselves a little key. All right, and the key is based off the 2 units that you're dealing with. So we have feet and seconds. So I'm going to make a little key that puts feet over seconds. Now, it doesn't matter which way you do this, but when you're talking about the speed of something, it's usually the distance over the time. If you think about a car, you always say miles per hour. You do the distance first, you do the time second. So, if we look at the problem, we went 89 feet. So, I said feet was on top, so I put the 89 on top in 0.8 seconds. So, the 0.8 goes on the bottom. Now, I want to know the speed. And the speed is always how far you can go in just one of whatever time you're measuring in. Miles per hour is how many miles you go in 1 hour. Feet per second is how many feet we go in 1 second. So I'm going to put a 1 down there for the seconds, and then the x is going to be the feet that I'm traveling. All right, now that I have this set up, I just cross multiply. So I get 0.8x equals 89. Divide by 0.8, divide by 0.8. And what I'm going to see is that x equals 111.25. And if I wanted to put a unit on this, this would be feet per second. So I'm going 111.25 feet for every second. Okay, so that's the final answer for that one. All right, let's take a look at number 4. The chart below compares 2 runners, so we've got Greg and Dave. Based on the information in this chart, state which runner has the faster rate. Justify your answer. All right, so we're pretty much going to do the same exact thing that we did up above, only we're going to do it twice. We're going to do it once for Greg, and we're going to do it once for Dave, and we're going to see who's faster. But the process is pretty much exactly the same. We've got 2 units. This time, instead of feet and seconds, we've got miles an hour. So I'm going to make my key miles over hours. And then I'm going to set up my proportions. Greg went 11 miles in 2 hours. If I want his speed, I want to know how far he's going in just 1 hour. So once I have that set up, I've got 11 times 1 is 11, 2 times x is 2x, divide by 2, divide by 2, and I get 5.5 equals x. And again, if we wanted to put a unit on this, this is miles over hours. So it's 5.5 miles per hour. All right, now let's do the same thing for Dave and see who's faster. All right, so here we've got 17 miles. Dave traveled 17 miles in 3 hours. So let's see how far he travels in just 1 hour. All right, so again, we'll cross multiply. We'll get 3x equals 17. We'll divide both sides by 3. And we end up with x equals 5.6 repeating. And again, that's miles per hour. All right, so all good work, but we want to make sure we actually answer the question. So it says state which runner has the faster rate. So once we've done our work, it's pretty obvious. Dave is just a little bit faster. He's 5.6 repeating miles per hour, where Greg is only 5.5 miles per hour. So we just want to write a little sentence that says Dave has, let me move the paper over a little bit. Dave has the faster rate. Okay, I hope this was helpful. We're almost done. Finals coming up. So keep studying and have a good day.